All right, ladies and gentlemen, here you are on the last bonding rule. This is bonding rule number 3. So rule number 3 is that only valence electrons matter. And again, remember that this word valence means outside. Now, this rule is probably the best rule and should be your favorite because it is a giant shortcut. It means we don't have to draw every single electron anymore. So for chlorine, which has 17 electrons, you don't have to draw all 17 dots. You don't have to draw the Bohr model, which looks like the circle. But there are a couple of things you do have to do. You must, I put it in capitals, must put the atomic symbol in the center so you know which atom you're talking about. Otherwise, chlorine and fluorine look exactly the same because they both have 7 valence electrons. Now, you can draw these valence electrons in any order so long as you have the right numbers. Especially when we talk about covalent compounds, we're going to end up rearranging them all anyway, so just make sure that you have the right numbers somewhere on your atom. So in this example, I'm going to compare the Bohr model and the Lewis structure for phosphorus. So phosphorus is atomic number 15. So if I draw the Bohr model, I'm going to start with my circles. And I have 2 electrons in the middle, and then 1, 2, 3, 4, 5, 6, 7, 8. I'm at 10, and I've got 5 more. 1, 2, 3, 4, and 5. So this is the Bohr model for phosphorus. I've drawn all 15 electrons, 2 on the inside shell, 8 on the outside shell, and then I would have had 8, but I ran out, so I only have 5 on the last outsidemost shell, the valence shell for phosphorus. Now, we are sick of drawing all these electrons, so we can instead draw the Lewis structure for phosphorus following rule number 3. So I'm going to start by putting the atomic symbol, P is for phosphorus, on the center of my Lewis structure, and I have 5 valence electrons to put around phosphorus. And I'm going to spread mine out because I know that electrons are negative and that like charges repel each other. So I'm going to put 1 here, and 1 on the bottom, and 1 on the side, and I'll put 2 on the top. And there are my 5 valence electrons for phosphorus, and this is the Lewis structure right here. Now, Lewis structures are great because they're a shortcut. We don't have to draw all the electrons, but they can be dangerous if we're not careful. We have to know already, walking into drawing this picture, how many valence electrons your atom has. The Bohr diagram is really nice because it helps us figure out how many valence electrons we have. So you can either draw the Bohr diagram to figure it out, or you can look at the periodic table. I also know that phosphorus has 5 valence electrons based on the column that it's in the periodic table. But if you already know how many valence electrons an atom is supposed to have, go right ahead and draw the Lewis structure. Now, the other great thing about Lewis structures is that they can show bonding, particularly in covalent bonds. So a line is the same thing as a shared pair of electrons. In the rule number 1 video, we talked about carbon and how carbon has 4 valence electrons and how it can bond with hydrogen. And hydrogen has 1 each, so here's hydrogen contributing its electrons to form covalent bonds. And we see that here we have a shared pair of electrons, and we have a shared pair here, and here, and here, and these are the 4 covalent bonds. Well, instead of drawing every single dot, we can instead draw a line. And that looks something like this. So if I were to draw the dots back in on this diagram, here are carbon's 4 valence electrons, and then hydrogen's go here next to the hydrogen. And so we have these lines here that indicate that these electrons are shared. So each line indicates 2 electrons, 1 from each atom. And so this yet is even more of a time saver, so we can draw lines instead of dots. So that is rule number 3, both in how we can draw it for a single atom and how we can use it to draw covalent bonds.